Okay, here is a grade 11 question 4 from the November 2018 question paper. It's about practical to determine Newton's second law. So it says learners investigate the relationship between the mass of an object and the acceleration it experiences when a constant net force is applied to the object. Okay, so we've been looking at mass, acceleration, and there's a constant net force. They use their results to draw the graph, state Newton's second law of motion in words. So now it says to you, when a resultant force acts on an object, the object will accelerate in the direction of the force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. So this law says to you that the acceleration is inversely proportional to the mass. And so if you plotted a graph of A against M, goodness me, that does not look like an M, you would get an inverse proportional relationship graph. Okay, I think it looks like that. But if you plot a graph of the acceleration versus 1 over the mass, you will end up with this graph looking like this. Okay, the same way that if you were to plot 1 over A against M, you end up with this graph that we've got a picture of over here, because the relationship is an inverse relationship. Okay, so the only way to get a straight line graph out of it is to invert one of the two things, acceleration or mass, and then plot the graph. So this graph is showing you that you have got a indirectly relationship because we've plotted 1 over A against M. Okay, so it says calculate the gradient of the graph. In all gradient calculations, you need to show a gradient formula. So it doesn't matter what formula you use. From maths, I like to use the change in y over the change in x with the little triangle. Okay, so show first of all your gradient formula. You need to show your gradient formula. Then you need to show which values you've taken. And when we say change in y over change in x, we have to do a subtraction sum. Okay, so what I'm going to do is I'm going to pick this point which is on the graph, yeah, and which is very clearly lining up with something. Okay, and I'm going to pick this point here because my graph is going through the origin. Okay, so I know this point here, the origin, if I were to give it x and y values, is 0, 0. I have to show the 0 substitution. If you're finding a gradient, you are finding the difference in two values, you definitely need to show the second value. So if we look at this point over here and we were to make it into an ordered pair, like in maths, the x coordinate is 1,25, the y coordinate is 2,5. Okay, and that one is obviously 0, 0. So when we work the gradient, it's the change in y over the change in x. So the y value for this point over here is 2.5, and the other y value we chose was 0, 0. Was 0. And then the x value is 1,25, and my other x value was 0 again. So I have 2,5 minus 0 over 1,25 minus 0, and I get a value of 2. So the gradient of the graph is 2. Then it says to you, hence. Now when you see hence, it means you've got to use the thing that you previously used to help you. Yeah, one thing leads to another, hence. So it says determine the net force applied on the object. Well, if we calculated the gradient, what were we actually calculating here? When we look at our graph, the change in y over the change in x, what was on the y-axis was 1 over a. What was on the x-axis? M. Okay, so if I look at 1 over a divided by m, I can mathematically write this as 1 over a times the inverse of m, because isn't divided by m is the same as timesing by 1 over m. So I've got 1 over ma for the gradient of the graph. And if we know Newton's second law, we know it gives you the formula F net equals ma. So it says, hence determine the net force applied on the object during the experiment. Well, we've got that this value 2 is equivalent to 1 over ma, yeah? 2 is equivalent to 1 over ma. And so this is equivalent to 1 over f. So if I want to find f, it's going to be the inverse of 2, 1 over 2. So the f is going to be a 0.5 newtons, okay? 1 over the gradient of the graph. Now it says, write down a conclusion for this experiment. So what were we trying to prove? We were trying to prove Newton's second law. So what did we plot? 1 over the acceleration against the mass. So what conclusion have we got? When you write your conclusion, try to refer back to the law and write it in such a way that it is confirming the law. And if you use the words that you've memorized for the law, it will help you make sure that you've put all the important points in. So what are the important points here? Acceleration is inversely proportional to the mass of the object. Okay, I'm writing in shorthand. So these are my two variables. The acceleration is inversely proportional to the mass of the object. But what was my controlled variable? My controlled variable was a constant net force. So my conclusion must also mention my controlled variable. These are my two variables, the one that I changed, the one that I measured, okay? So acceleration is inversely proportional to the mass of the object provided a constant net force is applied. Okay, so you need something like that that mentions the two variables and anything that you've kept constant, the special reaction conditions. So acceleration is inversely proportional to the mass of the object provided a constant net force is applied.